Hello there! Welcome to Mathematics Alive, Strategies in Problem Solving Part 2, Applying Formulas in Geometry. Here are the common formulas in geometry. Formulas for perimeters. We have the perimeter of a triangle is equal to A plus B plus C. The perimeter of a square is equal to 4 times S. The perimeter of a rectangle is equal to twice the length plus twice the width. And the perimeter of a regular polygon of side S and the number of sides is n is equal to P is equal to n times S. And for the circle, the perimeter is equal to the circumference, which is 2 times pi times the radius r. Areas. For the area of the triangle, we have A is equal to 1/2 of the base times the height. Square, area is equal to S squared. Rectangle, area is equal to length times width. Parallelogram, area is equal to base times height. And trapezoid, area is equal to 1/2 of base 1 plus base 2 times the height. For the volumes, we have the volume of a cube is equal to S cubed. The volume of a rectangular prism is equal to length times width times height. And the volume of a square base pyramid is equal to 1/3 of the area of the base times the height, or 1/3 of S squared times the height. For the cylinder, the volume of a cylinder is equal to pi r squared h. The volume of a cone is 1/3 pi r squared h, or 1/3 of the volume of a cylinder with the same height and radius. And the volume of a sphere is equal to 4/3 pi r cubed. The sum of the angles in a triangle is equal to 180 degrees, and the Pythagorean Theorem, c squared is equal to a squared plus b squared, where c is equal to the hypotenuse and a and b are the legs of a right triangle. Let's have some examples. Number 1. Triangle ABC has the following angle measure. Angle B is 10 more than angle A, and angle C is 10 less than angle A. What are the measures of the three angles? Strategy: use a variable and apply a formula. So let x be the measure of angle A. Then, the measure of angle B is equal to x plus 10, and the measure of angle C is equal to x minus 10. So, adding the three angles, we have x plus 10 plus x minus 10 is equal to 180 degrees. So, we add this 3 and we have 3x is equal to 180 degrees. Dividing both sides of the equation by 3, we have x is equal to 60 degrees. Therefore, the measure of angle A is equal to 60 degrees. The measure of angle B is equal to 60 plus 10, or 70 degrees. And the measure of angle C is 60 minus 10, or 50 degrees. Checking, getting the sum of the three angles, we have 180 degrees. Problem number 2. Find the length of the diagonal of a rectangular solid with length is equal to 5 centimeters, width is equal to 3 centimeters, and height is equal to 4 centimeters. So, the strategy is to draw a figure, use a formula, and the formula that we will use here is Pythagorean Theorem. If you look at the figure, here we have a right triangle here at the bottom and another right triangle here, which is standing. So we will solve for D, but we have to look for the value here of this hypotenuse, which we will call C. So solving for the diagonal C of the base by Pythagorean Theorem, and then we also solve for the diagonal D one more time using the Pythagorean Theorem. Solving for C, we have C squared is equal to 3 squared plus 5 squared. So C squared is equal to 9 plus 25 is equal to 34. Then solving for D squared, we have D squared is equal to 4 squared plus C squared, and D squared is equal to 16 plus 34 is equal to 50. The square root of 50 is equal to 5 square root of 2 centimeters. And we have an alternative solution. We can derive a formula so that we will have one formula for the whole problem. So equation 1 is for the formula for C. C squared is equal to L squared plus W squared. And then equation 2 is the formula for D. D squared is equal to H squared plus C squared. Then substitute equation 1 for C in equation 2. And we get equation 3, which is D squared is equal to H squared plus L squared plus W squared. The alternative solution is D squared is equal to H squared plus L squared plus W. With the given values, we have D squared is equal to 50, and then D is equal to square root of 50, or D is equal to 5 square root of 2 centimeters. Problem number 3. In the diagram below, LAT is an isosceles trapezoid with LE congruent to AT and LA is equal to 24 centimeters, the first base, and ET, the second base, is equal to 40 centimeters. So the altitude LF and AG are drawn. So we have LF and AG. What is the length of LF in centimeters, and what is the area of the trapezoid? So since the trapezoid is an isosceles trapezoid, we have AT is equal to LE, or LE is equal to 10 centimeters. And then since we have 24 here, LA is 24, and LA is parallel to FG, so FG here is also 24, leaving this line segments EF and line segment GT as the difference between 40 and 24. So we get the values of EF and GT since they are also equal. We have EF plus GT is equal to 40 minus 24 is equal to 16. And then dividing 16 by 2, we get the length of EF, which is 8 centimeters. Then we will just simplify the figure by getting the triangle in from this part. So we have 8 centimeters and then 10 centimeters for our hypotenuse. So we will solve for LF. And using the Pythagorean Theorem, we have LF squared is equal to 100 minus 64 is equal to 36. So LF is equal to square root of 36 or 6 centimeters. And the area of the trapezoid is equal to 1/2 of the base 1 plus base 2 times the height. Since base 1 is equal to 40, base 2 is equal to 24, then 1/2 of 40 plus 24 times the height 6 is equal to 196 centimeters. Problem number 4. Give the area of a circle circumscribing a square of diagonal 6 square root of 2 meters. So we have a given diagonal 6 square root of 2 meters, and we know that half of the diagonal is equal to the radius. So here is the solution. The formula for the area of the circle is equal to pi r squared, and our radius is 3 square root of 2 meters. So the area of the circle circumscribing the square is equal to pi square root of 2 times 3 squared, or 18 pi meters squared. Problem number 5. A cylinder has a height of 15 centimeters and a diameter of 12 centimeters. What is the volume of the cylinder in cubic centimeters, and what is the area of the label of the can or the lateral surface area? So first, we find the volume of the cylinder in cubic centimeters. We have the height. Given height is 15 centimeters, and the diameter is 12 centimeters, so we will divide it by 2, and we have a radius of 6 centimeters. So the formula for volume is pi r squared times h, and we get the volume is 540 pi centimeters cubed, or 1696.5 centimeter cubed. Then for letter B, what is the area of the label of the can, or the lateral surface area? The formula is 2 pi r times h, or the circumference of the circle times the height of the can. So given h is equal to 15 centimeters and r is equal to 6 centimeters, the lateral surface area is equal to 180 pi, or 565.5 centimeters squared. Problem number 6. An ice cream cone is 14 centimeters deep and 6 centimeters across the top. 2 spherical scoops of ice cream, 5 centimeters in diameter, are placed on top of the cone. If the ice cream is allowed to melt into the cone, will it overflow? So the given is the diameter of the ice cream cone. So we get the radius from there. We divide the diameter by 2 to get the radius. So we have the radius of the cone is 3 centimeters, and the radius of the sphere is 2.5 centimeters. And we will get the volume of the cone and the volume of the 2 scoops of ice cream separately, and then get the difference between the two. So for the volume of the cone, we have the formula 1/3 pi r squared h, and then the volume of the cone is equal to 42 pi centimeters cubed. For the volume of the 2 scoops of ice cream, we have twice the volume of the sphere, which is 4/3 pi r cubed, and we have a radius of 2.5 centimeters. So the volume of the 2 scoops of ice cream is equal to 41.67 pi centimeters cubed. Getting the difference, we have 0.33 pi centimeters cubed. Therefore, the ice cream will not overflow since the volume of the cone is greater than the volume of the 2 scoops of ice cream. Problem solving using formulas in geometry has so many practical applications in daily life. Learning to use formulas in geometry is very rewarding for any students. So please like, share, and subscribe to this channel by clicking the button below. Enjoy problem solving and thanks for watching. Bye-bye!